A quadratic formula is of the form ax squared plus bx plus c. Quadratic because of the second power on the x. So okay, you solve the quadratic by finding what values of x make that true. Now, there may be two solutions. There may be one, and there may be no real number solution. There are various methods covered in Math 40. We'll briefly cover them again now. There's solution by factoring, solution by square roots, solution by completing the square, and solution by the quadratic formula. You solve by factoring the quadratic, and use the zero factors rule. If a product equals 0, then one of the sums is 0. So for example, here you have x minus 2 times x minus 3 equals 0. Here it's already pre-factored. Okay, this product equals 0, so one of these two factors must be 0. Either x minus 2 is 0 or x plus 3 is 0. Now these are linear equations, easy enough to solve. X is 2 or x is negative 3 are the two solutions of this equation. Here it's not pre-factored. X squared minus 5x plus 6 equals 0. Now, okay, there's what I call the PQ method, which consists of finding numbers P and Q whose sum is the middle coefficient, in this case negative 5, and whose product is the last term, in this case 6. Now, all right, you can go by guessing or go by systematic search. Either way will do. Either way, you'll stumble upon the solution negative 2 and negative 3. Their product is negative 5. Their sum is negative 5. Their product is positive 6. Okay, so that means we can rewrite this equation as x minus 2 times x minus 3 equals 0. Okay, a product equals 0, therefore one of the factors is 0. X minus 2 is 0 or x minus 3 is 0, from which follow that x is 2 or x is 3. Now here we have something a little more complicated one. 2x squared plus 5x plus 3 is 0. To factor this, we'll need to use something called the AC method. Here's how it goes. To factor ax squared plus bx plus c, find a p and a q whose sum is the middle coefficient b, and whose product is a times c. That's unlike here, we would need one where the product is just c, because a equals 1. All right. Once you have this, p and q, then we write bx as px plus qx. So you get ax squared plus px, that plus qx plus c. And if you did it right, this will factor by grouping. We'll pull out a factor of x here, and then a common factor here, and then the result will be that we'll also have a common factor. For example, we have 2x squared plus 5x plus 3. We want to find a p and q whose sum is 5, and whose product is 2 times 3, which is 6. Well, that's not so difficult. 2 and 3 work fine. Their sum is 5, the product is 6. So 2x squared plus 5x plus 3 equals 0. We rewrite this 5x as 2x plus 3x, or excuse me, 3x plus 2x either way. Now we factor this by grouping. These first two terms, find their common factor, in this case, x times 2x plus 3. The next two terms, 2x plus 3, there's no common factor, so we pull out a common factor of 1, again, times 2x plus 3. But now the 2x plus 3 is a common factor. So you pull that out, and that times x plus 1. X plus 1 times 2x plus 3 equals a 0. That looks too much like a 6. I really should fix that in the canvas. What's this? 1-4, page 3. 6. All right, so one of these product is 6. One of the factors is this product is 0. One of the factors is 0. So either x plus 1 is 0 or 2x plus 3 is 0. All right, here we transpose x equals negative 1. We transpose the 3 and then the 2, x equals negative 3/2. So here are the two solutions, x equals negative 1 or x equals 3/2. A digression to why the AC method works. If you have ax squared plus bx plus c, and if you find p and q whose sum is the middle coefficient b, and whose product is a times c, then Since PQ equals AC, we can isolate Q, it equals AC over P. Now, and because B equals P plus Q, we rewrite Bx as Px plus Qx. Now, Qx is AC over P times X, because Q equals AC over P. And I'll write this, okay, so AX squared plus PX plus AC over PX plus C. I'll rewrite this C as CP divided by P for reasons that'll become clear in a moment. All right, now here, AX squared plus BX, pull out a common factor of X, that times AX plus P. AC over PX plus CP over P, pull out a common factor of C over P, and that'll be times AX plus P. We'll look at that. AX plus B, common factor. Pull it out, that'll be AX plus P times this, X plus C over P. And we have factored the quadratic. Okay, so those are various methods. Now, there's solution by square roots. If X squared equals C, then X squared minus C equals 0. C is the square of the square root of C. So X squared minus the square of root C equals 0. Difference of squares equals difference times sum. X minus root C times X plus root C. And then this is 0 or this is 0, so X is root C, or X equals minus root C. We abbreviate that by this notation. X equals plus or minus root C. This is the plus or minus sign. It really means two different numbers. So for example, X squared equals 49. Well, then X equals plus or minus root 49. So X equals 7 or X equals negative 7. Here, 2X squared equals 100. Divide both sides by 2. X squared equals 50. So X equals plus or minus root 50. Okay, we can simplify this root by pulling the largest square factor of 50, which is 25. So X equals plus or minus root 25 root 2. Root 25 is just a 5, so X equals plus or minus 5 root 2. Yeah, we're getting gnarly. 3 times the square of X minus 2 equals 36. To solve that, first divide by 3, so X minus 2 squared equals 12. Now, okay, so square equals 12, so this thing in the middle, X minus 2, be plus or minus root 12. Add, transpose the 2, X equals 2 plus or minus, well, root 12 we can rewrite as root 4 root 3. And root 4 is just 2, so X will equal 2 plus or minus 2 root 2. These are the two solutions to this equation. We can solve, okay, we can generalize solutions by square roots by something called completing the square. The idea is you have X squared plus BX. We want to know what to add to that to turn it into a completed square. Here's the general formula. If you have X squared plus BX, divide by 2, that's B over 2. Square that is B squared over 4. And if you add that back here, then the result will equal the square of X plus this B over 2 here. So this goes here and this goes here, and that's completing the square. So for example, X squared plus 6X plus what equals what squared? Okay, well, here we go. X squared plus 6X. You divide that 6 by 2, you get a 3. Square that, you get a 9. If you add that 9 back in there, the result will be the square of X plus this 3. Or Y squared plus 7Y plus what equals what? Well, Y squared plus 7Y. Half of the 7 is 7 halves. Square that, you get 49 fourths. So if you add that back in here, Y squared plus 7Y equals plus 49 fourths will equal the square of Y plus this 7 halves. The idea is we can use completing the square plus solution by square roots to solve quadratics. For example, here is X squared minus 12X plus 1. The first thing to do is move the 1 to the other side just to get it out of the way. The next thing to do is to complete the square. In this case, we divide both negative 12 by 2 and get a negative 6. Square the result, it gets a 36. And now we add that 36 to both sides of the equation to keep it balanced. So on the left side, X squared minus 12X plus 36 is negative 1 plus 36. Now this left side, will be the square of x minus this 6. And the right side, -1 plus 36 is 35. Okay, x minus 6 all squared equals 35. Now we use square roots, solution by square roots. This squared equals 35, therefore this, x minus 6, will be plus or minus root 35. Then add 6 to both sides and get x equals 6 plus or minus the square root of 35. Those are the solutions. Here's a more complicated one. 12t squared minus 5t minus 3 equals 0. Now the trouble here is this 12 in front of the t squared. Well, that's easy enough to fix. We'll divide throughout by 12. So you get t squared minus 5/12 t minus 1/4 equals 0. Next, we transpose the 1/4 to get it out of the way. T squared minus 5/12 t equals 1/4. Now, complete the square. We take half of this middle coefficient, that's -5 over 30 over 24. Square the result, that's 25 over 576. Add that to both sides of the equation to keep it balanced. So t squared minus 5/12 t plus 25 over 576 equals 1/4 plus 25 over 576. Left side is a completed square of t minus 5/24 from here. The square of 5 minus t minus 5/24 equals, now if we work this out, it's 169 over 576. All right, great. Now we take square roots. T minus 5/12 is plus or minus root 169 over 576. This, fortunately, is a perfect square. So you get, which is in fact 13/24. Transpose 5/24. You get t is 5/24 plus or minus 13/24. And after doing the arithmetic, we get t is -1/3 or t equals 3/4. These are the solutions to this. Or t squared plus 20t plus 25 equals 0. Again, we transpose the 25. Then complete the square. Half of 20 is 10, squared is 100, add to both sides. T squared plus 20t plus 100 equals -25 plus 100 is 75. This left side will be the square of t plus this 10 here. T plus 10 all squared equals 75. Now we take square roots. T plus 10 equals plus or minus root 75, which you can rewrite as 5√3. And subtract 10 from both sides, so get t equals -10 plus or minus 5√3. These are the solutions to this equation. Here's the equation: x squared plus 8x plus 6 equals 0. Transpose the 6. X squared plus 8x is -6. Okay, now complete the square. Half of 8 is 4, squared is 16. Add that to both sides. So x squared plus 8x plus 16 equals 16 minus 6. The left side is the square of x plus this 4 here. Square of x plus 4 equals 16 minus 6 is 10. All right, now for the square roots. X plus 4 equals plus or minus root 10s. So x equals -4 plus or minus root 10. Now we can generalize completing the square. Let's do it in the general case. Ax squared plus bx plus c equals 0. We'll use the same procedure as completing the square, only on this general formula. Okay, first off, this a is an inconvenience. Okay, so we'll in front of the x squared. So we'll divide throughout by a and get the equation. X squared plus b over a, x plus c over a equals, well, 0 over a, which is 0. Then we transpose the c over a. So x squared plus b over a x equals -c over a. Now to complete the square, we take half of this coefficient. And I can get b over 2a. Square the result, that's b squared over 4a squared. Add that to both sides. So x squared plus b over ax plus b squared over 4a squared equals b squared over 4a squared minus c over a. Now, sorry, I have a cat who is, of course, as typical for cats, is insisting on standing and pacing between me and the computer monitor. Pay attention to me, to me. Anyhow. All right, so where were we? All right, the left side is a square of x plus b over 2a. Here, square of x plus b over 2a. The right side, b squared over 4a squared. After a bit of algebra, that's going to be b squared minus 4ac over 4a squared. All right, we have a square. You can take square roots. X plus b over 2a equals the square root of the right side. That'll be plus and minus root b squared minus 4a squared c, all that over root 4a squared. Root 4a squared is 2a. Transpose the b over 2a and get x equals minus b over 2a plus and minus root of b squared minus 4ac, all that over 2a. It's traditional to put this over a common denominator of 2a and thus get x equals minus b equals minus b plus and minus root b squared minus 4ac, all that divided by 2a. That's the quadratic formula. Okay, so for example, 2x squared plus x minus 3 equals 0. A is 2, b is 1, this is a 1x, c is minus 3. So x equals minus b plus and minus root of b squared minus 4ac all over 2a. Okay, putting in this 1 for b here and here, putting in this 2 for a here and here, putting this negative 3 for c here. Okay, a bit of arithmetic, negative 1 plus or minus root 25 over 4. Root 25 is 5, so x is negative 1 plus or minus 5 all over 4, which after simplifying gets you x equals negative 3 halves, or x equals 1. These are the solutions of this. Now here's another equation, 12t squared minus 5t minus 2 equals 0. So a is 12, b is negative 5, and c is negative 2. So using the formula, x equals minus b plus or minus b squared minus 4ac over 2a. b negative 5 goes here and here. A 12 goes here and here. C negative 2 goes here. And so you get 5 plus or minus root 121 over 24. Root 121 is 11, so 5 is plus or minus 11 over 24, which gets you negative 1, x is negative 1/4, or x equals 2/3. Now, this, in the quadratic formula, we have a kind of a sticky part, b squared minus 4ac. It looks a little complicated, doesn't it? Well, it should be, it is. All right, here we go. We give this name, the discriminant, b squared minus 4ac equals, called the discriminant. The idea being is that we're taking the square root of this discriminant. And the square root is only defined when it's up on numbers greater than or equal to 0. If b squared minus 4ac is greater than 0, then you have 2 real roots. And that'd be like when a quadratic passes to the x-axis at 2 points. If b squared minus 4ac equals 0, then this is plus or minus root 0, which is plus or minus 0, which just cancels out entirely. So you get 1 root, called a double root. That's when we have a parabola that touches the x-axis at just 1 point. So imagine pulling this parabola up until it's just about to leave. If b squared minus 4ac is less than 0, then the parabola misses it. You get a square root of a negative number, which is not a real number. So you have 2 complex roots, the imaginary solutions, no real number roots. And also, if b squared minus 4ac equals the square of an integer, then you'll get rational roots. If not, you get irrational roots. So, okay, some examples. 4x squared minus 4x plus 1, what kind of roots? Well, we choose the discriminant, that's negative 4 squared minus 4 times 4 times 1, which comes out to 16 minus 16, or 0. Discriminant is 0, so there's a single repeated root. 5x squared plus x plus 2. Discriminant is here 1 for b squared minus 4 times 5 times 2, a and c. Works out to negative 39. This is negative, and it is not a square of an integer, or even negative the square of an integer. So the results are two irrational complex roots. Now here you have something deliberately annoying. X times 2x minus 3 equals 20. All right, so you have to distribute the x, transpose the 20. You get 2x squared minus 3x minus 20 equals 0. All right. Discriminant, excuse me, is the square of -3 minus 4 times 2 times -20 here and here. Comes out 1 to 69, which is 13 squared. So there are two rational real roots. Here, 3x squared minus 10 equals 0. The discriminant, well, a is 3, b is 0, c is -10. So the discriminant is b squared minus 4ac, 0 squared minus 4 times 3 times -20, which is 120, which is positive, but not the square of a whole number. So you'll have two irrational real roots.